Hello everyone, welcome to class 2 of CS2. I'm Pratap from Smears Education Solutions. I'll give an introduction to Markov chains in today's class through examples and discuss more in the subsequent classes. This is in continuation to class 1. So those who are new to this, who didn't watch class 1, please follow the link above. Go to class 1, watch it properly, then come here. You'll be able to follow. This is the first example I've written. Here we talk about Markov chains. Now, when it comes to stochastic process, it's very important to understand what is a Markov chain. We have time points here. Suppose you want to predict for fourth. If you have two states, you want to predict whether it will rain tomorrow or not. Suppose it's raining here and not raining. These are the two states. You want to predict whether it will rain tomorrow or not. If you use only today's information, whether it rained or not, we are here. We have all information available. We know today's information. We know yesterday's information. We have 1 month information. We have the whole past history with us. We can use last 1 year, 10 year information also. However, when it comes to Markov chains, we are interested in one step information. If you want to predict whether it will rain tomorrow or not, you should be able to predict using only today's weather conditions. I'll give you the formal definition in the next class. Try to understand how to use in problems. Suppose that the chance of raining tomorrow depends on previous weather conditions only through whether it's raining today and not on the past weather conditions. Suppose also that if it rains today, then it will rain tomorrow with probability zero point 0.6. Raining, zero point 0.6. So here raining to raining 0.6. This is raining 2 to 2.6, you see here. And this is not raining. One is not raining. This is not raining. We have to denote by numbers all the time. We have two states here. Not raining is 1, raining is 2. So this is 0.6. The other one is not given because the total probability is 1. If we are at 2 here today, that means it's raining today. It's raining today. Tomorrow, either it will rain or it will not rain. So one probability is given 0.6, then the other will be 0.4. Similarly here, if it doesn't rain today, then it will rain tomorrow with probability 0.7. Not raining, that means 1. If we are at 1 today, we are not using past conditions, only today's conditions we are using. If it's not raining today, then there is a 70% probability that it will rain tomorrow. So 1 to 2, 70%. Okay. If we are at 1 today, there is a 70% chance that we'll make a transition to this. We'll go to 2 tomorrow, 70% given. This is not given because there are only two choices. We have two states here. We're predicting whether it will rain tomorrow or not. So this will be 30% automatically, 70-30. And if we are at 2 today, if it's raining, then also there are two chances today. It might rain, it might not rain. So we have the transition matrix here. If we are at 1 today, what are the possibilities? If we are at 2 today, what are the possibilities? If we are at 1 today, then 1 to 1 is zero point 0.3. Whatever way you write, it doesn't matter. Ultimately, you have to write the transition matrix properly. 1 to 1 zero point 0.3, 1 to 2 zero point 0.7, 1 to 2 zero point 0.7. See here. This is the transition matrix. And then 2 to 1 zero point 0.4, this is not given. 2 to 2 zero point 0.6, this is given. So this is our transition matrix. Now, the initial probabilities you have to know to proceed further. Because we are using one step, using today's conditions, today's weather conditions, we'll be able to forecast for tomorrow. Using tomorrow's weather condition, we'll be able to forecast for day after tomorrow. Using day after tomorrow's condition, we'll be able to forecast then, not now. Then we'll be able to forecast for the next day. Now, you have three transition matrix. Because when we talk about transition matrix, we talk about only 2 points, 2 time points, here to here. If something is here, how it will be tomorrow. That's what we are doing. Tomorrow or maybe next year, next hour, whatever. It depends on the time interval. Now we are interested in this part of the diagram. And we have one transition matrix. And all probabilities are already there. But what is the question? Given that it rains today, given that it rains today, there is 100% probability that it rained, because this is a sample now. We have the information. Will not say 10%, 90% that way. Given that it rains today, that means there is a 100% probability that it rained. It rained means 1. Probability is 1. What is the probability that it will rain day after tomorrow? That means we want about this. Whether it will rain or not, we have to predict day after tomorrow. The probability we have to specify. Tomorrow probability we know. Given that it rains today means we are at 2 today. We are here. We are here, and we can use the transition matrix. We can say about tomorrow. The probabilities are given from 2. Tomorrow, the probability that from 2 to 2.6, given that it rains today, then what is the probability that it will rain day after tomorrow? What is the probability that it will rain tomorrow? That is directly there, 0.6. We know it. Now see here, these are the initial probabilities, initial probability distribution you can say. This is time 1. 1 probabilities are written here. Let me change the ink to black. Now, these are the probabilities at 1, 0 and 1, x1. This is the random variable at 1, that is x1. X1 is 1, this is 0, because it's given. This is given. And the probability that x1 is equal to 2, 2 means it's raining, is 1. This is what given. It rained today. It rains today. That means there is a 100% probability. You will take 1 and this one 0. Then these are directly given 0.4, 0.6. Even we can use matrix multiplication, we can get the same thing, because we'll use this matrix with the initial one will multiply. You will get the same thing. There will be no difference. However, you have to predict for day after tomorrow, not tomorrow. So we have to cross 2 time steps from here to here. And you can continue multiplying matrices. You start from here. This is the initial probability distribution. You will come across this more frequently later. Now, this is the initial probability distribution, and this is the transition matrix. The conditional probabilities are here, And this is the initial distribution. These are the total probabilities at time 1. This 0, 1 we have written here. And this is the transition matrix from here. Multiply, you get this zero point 0.4, zero point 0.6, 0.4, 0.6. Now, from zero point 0.4, zero point 0.6, you multiply once again this one, you will go to the next one. So from here to here, we have the transition matrix and we know the probabilities here 0, 1. And using the probabilities and the transition matrix, importantly remember, we can find the total probabilities at 2. And we got the probabilities 2 also. See here, these numbers should match these numbers. Now, using the total probabilities here, you multiply the transition matrix, this one, you will get the total probabilities here at time 3. So we got 0.36, 0.64, 0.36, 0.64, probability set 3. This is time point 3. Probability that x3 is 1 is the first one, 0.36. Probability that x3 is equal to 2, that is 0.64. Here, from here, you can write these two. So you need to multiply the transition matrix time and again. Let me take this opportunity to tell you that this is a homogeneous Markov chain. Homogeneous means the transition matrix will not change. The pattern will not change. If the transition matrix will change, then that is non-homogeneous. Now we are discussing about discrete time, discrete space, and homogeneous Markov chains. Slowly we'll proceed further. So we have taken the same transition matrix here from this point to this point, from this point to this point, from this point to this point. This is the same. So we got these two. We got this one at time 3, that means after 2 days, day after tomorrow, the condition that it will be 1 is 0.36, the condition that it will be 2 is 0.64. So what is the question then? What is the probability that it will rain day after tomorrow? It will rain day after tomorrow. That means you are predicting 2. Probability that x3 will be equal to 2. So your answer will be 0.64. Your answer should be 0.64. This one. Let's go to the next problem. We have another similar problem, but a little bit more here. A man drives a car or catches a train to go to the office each day. He never goes 2 days in a row by train, but if he drives one day, then the next day he just is likely to drive again as he is to travel by train. Now, suppose that on the first day of the week, the man tosses a fair dice and drove to work if and only if a 6 appeared. It's not like 0 and 1 probability. This will give you initial probability. And here there are two questions. One is third day. Find also the probability that he drives to work in the long run. There are two problems here. This gives you the initial probability distribution. Remember in the last problem, the initial probability distribution was given that it rains today. So it rained or it didn't rain. At the end of the day, you know, and you know that it rained. So 100%, we have taken 0, 1. Now go back to this question. So there is no 0, 1 here. Suppose that on the first day of the week, the man tosses a fair dice and drove to work if and only if a 6 appeared. So the probability is 1 by 6, 5 by 6. Instead of taking 0, 1 or 1, 0, here chance factor, even he has no idea. That's why the initial distribution, if you see, that is here, Let's write the transition matrix here. Even it's here, we can verify directly. 1 to 1 it's given. There is no way 1 to 1. 1 I mentioned here by train. Suppose this is house and this is office. Now there are two ways. Either he can go by train, big one, or he will go by car. This is the road. This is train line. Now what it says, he never goes 2 days in a row by train. Suppose he traveled today by train, the tomorrow he will not go by train. 100%. So we have taken one for train, two for car. So train to train, today train, tomorrow train, that will not happen. So if today is train, tomorrow it will not be train. It will be 1 to 200%. That's how we have 1 here, 1 to 2, probability 1. But 1 to 1, 0, because there is no way he will travel 2 days by train. So this is 0%. 1 to 1, 0%, 1 to 2, 100%. Now start from 2. If you drop today, there is a equal chance. You might go by 2 or 1, 50%, 50%. This is what given. So zero point 0.5, zero point 0.5. This is the transition matrix. The transition matrix will be given initially for some time, and then you will be able to estimate also from past experience. I'm not going to that. So from the question, initially for the first 3 to 4 classes, you should be able to find the transition matrix and importantly, the initial probability distribution. When I say initial probability distribution, the distribution at 1, the distribution at 1 we need here. This is 0.1, this is 0.2, this is 0.3. So if you are starting from here, what happened here? Now suppose that on the first day of the week, the man tossed a fair dice and drove to work if and only if a 6 appeared. So driving by car probability is very less, only 1 by 6. Not driving by car, by a train with lot of documents is 5 by 6. So this is the initial distribution. This is given here. So start with the initial distribution and then you see how you are making a transition. You multiply that and get the probability next time. So the next time probability, the probability set time 2, you can find from here. You can link this way. This one is this one is this. Then again we are in homogeneous Markov chain. So multiply the same transition matrix once again to these probabilities. You will get the probabilities here. So again these numbers are here. Probability that x3 is equal to 1. 1 means traveling by train is 11 by 24. Probability that he will drive to office, that is 2, is 13 by 24. Okay, it was 5 by 6, 1 by 6, but now you will not toss, you will not roll a dice every day, only on first day. Now it was 5 by 6, 1 by 6 first day, but it's almost equal, 13 by 24, 11 by 24. The probability is high for 2. So driving by car is a little bit more, 13 by 24 is compared to 11 by 24. But it's only after 2 days. Third day. If today is the first day, we're talking about third day. Now the question is, the other question, the next one, find also the probability that he drives to work in the long run. After many days, what is the probability that he drives to work? We are talking about self help, driving by car, not by train. For that, we have to solve this equation. If you check here, 5 by 6, 1 by 6 is not equal to 1 by 12, 11 by 12. So, stationary distribution is something that is long run probability distribution. You can say steady state distribution. Here we have 0, 1, 0.5, 0.5, and xy here. Xy to xy you have to get. It should not change once again. So you need to solve the equations. You cross multiply this into this, that should be equal to x. This into this, that should be equal to y. I've written here two equations. And another equation, x plus y is equal to 1. That also you need to consider. Because though we got two equations here, there will be dependency. You should consider only one equation. The two are not same. Suppose I write x plus y is 5, 2x plus 2y is 10. They are not two equations. They are only, I mean, though they are two, there is only one equation. So in these cases, there will be one dependency. If you have a 3 cross 3 matrix, you will get three equations. There will be dependency. You will get effectively two equations only. Here we have a 2 cross 2 matrix. We have got two equations, so one will be useless. So you take any one. Suppose 0.5y is equal to x. I consider the first one, and second one, x plus y is equal to 1. You can use it. And then solve this to find x and y. That's all. So we got x1 by 3, y2 by 3. x1 by 3, y2 by 3. Okay. So what will happen in the long run if this continues? Then what will happen? 2/3 time he will drive to work, and 1/3 time he will go by train. That is the stationary distribution, steady state distribution, long run distribution. This is a very, very important example. NCD, no claim discount, no claims discount. If you have a bike or you have a car, then you must be paying the premiums for your policy. That is mandatory in India. In insurance, first time you have to pay the whole premium. You get no discount. If you have purchased a car recently, you must have paid full premium. Suppose it's 20,000 for 1 year, you pay full premium 20,000. During 1 year, suppose you purchase on 1 January 2020, up to 1 Jan 2021, this 20,000 premium will work. Okay, for 1 year, this is the premium. How about at the start of the next year, you have to pay another premium? They will not charge you 20,000 premium. If you pay 20,000 here they might give you some discount. The discount amount will depend on your driving experience. They will rate the policyholder. They rate the policyholders. That is called experience rating. They will rate you according to your driving experience. Suppose you didn't make a claim during the last year. Now you are on 1 January 2021. They will give you 25% discount. 25% discount, yes. And then the next one is state 3, that is 50% discount. 50% discount. 25% discount means one fourth discount. One fourth means 5,000. Next time you have to pay only 15,000 amount. The next year, if it's a claim free year, then they will give 50% discount on the premium. They will give you 50% discount, not this one, on the main premium. That means you have to pay 10,000 only. Then in the subsequent year, if you will not make a claim, then they will not give you any more discount. There is a level, there is a cap, flow, I mean, your ceiling, you can say, that is the highest level, 10,000. After that, you will not get anything. So this is capped at 50%. However, if you think that you will not get any discount, you will make an accident, you claim, then obviously next time they will give a demotion. They will demote you to the next lower level. What will happen? They will bring back to the next level. There are three levels here. Let's go through the question once. If a policyholder doesn't claim during a year, then he or she will get discount on the premiums amount next year, and same might continue for some time till he or she reaches the maximum discount level, promoted to the highest level, 60% in the example. However, if he claims during any year, he will be demoted to the lower level, and it continues till he reaches the lowest level. Here, promotion is one level, demotion is one level. You will come across the problems where promotion will be one, but demotion might be two levels. There are a variety of problems, but this is the first problem. And the initial distribution is given here, 100. 100 means, why 100? It should always be 100, because first time, suppose this is one, 10,000 policyholders, they've taken the car insurance policy. This is a new insurance company, general insurance company, and there are 500 or 1,000 people, they've taken policies, all will be here. One means 0% discount, no discount at all, because this is the starting first year, no discount. All are here, 0, 0, no person is here. Next year, what will happen? Some people will go to this. I've written two types of discount here, 60%. So we'll make it 60%. Okay. If he reaches promoted to the highest level, the other one must be 30%. Yeah, 30%, 0%, state 0, 0% discount is state 0 once again. This is state 0, and state 1 is 30% discount. Okay. Nobody will get. So in terms of numbers, all the 10,000, they will be here in this state. Insurance company will rate them 0. If somebody will not claim, they will promote to this level, and they will rate that policyholder 1. Nobody will go here. In 1 year, they will not give two promotion. Some will stay here. Those who will claim, they will be in 0% discount. That is state 0. There are three states, 0, 1, 2. Here 0% discount, here 30% discount, here 60% discount. There are two problems actually. They got mixed up. Okay, no problem. 0%, 30%, 60%. So 0% is 0, 30% is 1, this is 2. So nobody will go from here to here. They will not give promotion, two promotions at the same time. They will not give two promotions, 0 to 2, no chance. Okay, no probability. So here to here, here to here, two things will happen. You can check the transition matrix, you will be able to know. The transition matrix 1 to 1, 1 by 4, 1 to 2, 3 by 4, and 1 to 3, 0. 1 to 3, there is no possibility. Then 2 to 1, 1 by 4, 2 to 2, 0, 2 to 2, that means you consider any 2 years, t to t plus 1. Remember, when we talk about this transition matrix, we consider any 2 points. Will not worry what are the 2 points, because we are doing now homogeneous Markov chains. Now the probabilities of moving from here to here are given. From here, How many chances are there? I'm not saying this is 0 or 1 first time. This could be 30, 31. T to T plus 1. So 1 to 1 is 25%. This is 25%. That's why 1 by 4. That means 25% they will make a claim during the year. They will not get promotion. They are here and they will be here only. 0% discount. 1 to 2, 3 by 4. 75% they will go from here to here. They will get promotion and they will go to this level and they will get discount. 30% discount in our case. That is level 2. And 1 to 3 there is no way one can go from here to here. Now start from 2. Someone is enjoying here and the rating is given from the company. The rating is 2. I mean, here I've written 1 to 3. Okay, all right. Okay, you make it 1 to 3. Actually, I've not written. Anyway, let's not go to that. 1 2 3. Yeah, it's good that you are getting all this confusion now, and this is a confusion in CS2. 1 to 3. Okay, 1 to 3, 1 to 3. Now 1 to 1, 1 to 2, 1 to 3. Then 2. 2 to 1 is 1 by 4. Here 2 to 1, again 25% they will claim staying at this level. They were enjoying discounts 30%, and they were rated 2 by the company. Now out of them 25% will make a claim and they will be demoted to 0% discount level 1. How about this? 2 to 2, nobody will be there. During this year, either policyholders will claim or not claim. If they will not claim, they will be promoted. If they will claim, they will be demoted. Nobody will be here. Nobody will be in the same level. So 2 to 2, 0. Typically, 2 to 3, 3 by 4. Again, 25, 75%. Yeah. Then 3 to 1, 0. 3 to 1 means you are at 3 and you make a claim during this year due to some accidents. You make a claim, next time they will demote you this level. You are enjoying 60% discount here, but they will next time, next premium, they will give you only 30% discount. One level. So 3 to 2 is there. 3 to 3 is also there. What is 3 to 3? You are at 3, you are enjoying full discount 60%. Company gave you a rating 3. Next time also they will rate 3. Principal of a college, there is no more promotion. You are a principal, you will be principal only. That is the highest level. You are a president, you will be president. That is the highest level. You can't go beyond that. So you will enjoy 60% discount, but you should not claim during the year. So that's how this is 3 by 4. So these numbers will be given for you. It's not that you are finding. This is given. Transition matrix is given to you. In this case, even if this is not given, you can take initial probability distribution 100 because all the policyholders, they will start from 1 here. The transition matrix is given for any 2 points. So if you start from 1, you can apply the transition matrix for 1 to 2 as well. And you can go from year to year and you can check how the people, they are going from one place to the other place. This is called state diagram. State diagram. Now you are at 0. I mean 1, I change it to 1. 0% discount means 1. You are at 1. What is the probability that you will go to 1, 1 by 4? So you can make a self loop, 25%. This one. Let me change the ink. So 1 to 1, 1 to 1 means self loop. If you have 1 to 2, you have to draw this way, 1 to 2. If you have 1 to 3, you have to draw this way. 1 to 3 is 0 here. So there is no arrow going from 1 to 3. There is no direct connection from 1 to 3. So 1 to 1 is 25%. 1 to 2 is 75%. These are 1 by 4, 3 by 4. Total value, total sum of these two is 1. Sum of all row probabilities will be always 1, not column probabilities. So from 0% discount, that means one level, you will be at one level or two level next time. So these two will be one. Now starting from two, either you will go to three or you will come back to one. If you add these two, that will be one. So two to zero and two to 0% discount, that is state one. Two to three. If you add these two, that will be one. You are at three now. Three to three, 75% given, and 3 to 2, 25% given. 3 to 3, 0 means you can't come to 0. I mean, level 1, 3 to level 1, 0. That means there is no direct way, there is no arrow like this. This is 0. You will see the state diagrams where lot of connections will be there. Okay. But here it's very simple. Only one promotion, one demotion. This is the highest level. You will stay there only. You loop there. And if you are here, you claim many all the years, you will stay here only. You will make a loop. You will be here. Now, in terms of probability, you start with 100, multiply the transition matrix. This is the probability next time. Means 25%, 75% it will become. And after another year, if you multiply, you get again 4 by 16, 3 by 16, 9 by 16. Now, this means actually, if this is the number line, all persons are here initially. All are here. Nobody is getting discount. Now, if you see second year, 25% only they will be here. So they will not get discount, but 75% are now here. They will get 30% discount. And nobody will get 60% discount. So these people, out of 10,000 policyholders, if you take 10,000, then 25%, 2,500, they will be here. And rest 7,500, they will get 30% discount next time. And nobody will get 60% discount. The following year, the probabilities are like this. So 4 by 16, that is the out of 16, 4 will get 4 by 16, the ratio. This fraction, they will get 0% discount. This fraction, they will get, because we have started from 100, 30% discount. These will get 60% discount. If you see the question, 6400 is given. This is starting with 100. If you multiply 6400, 6400 in number, then you have 0 here. The next time 1 4 3 4 you can make. Next time 4 by 16, 3 by 16. That way you have to do it for 3 times. You multiply this one, this transition matrix 3 times, because we have 3-year gap. We have started from 1 January 2014, and then you have to find on 1 January 2017. 1 January 2014 to 1 January 2017, 3 year. So you multiply 1, you will get 1 year, multiply 2, second year, multiply 1 second, you will get third year. That way you will be able to know how many are there. There is a third one also. It's not here. The third box is cut here. So you can multiply 1 second and you can see what numbers you are getting. Then you have to find the stationary distribution as well. Find the stationary distribution. Yeah, this is 1 year. This is 2 year. This is 3 year. If you take, this is 2014, 15, 16, 17. Yeah, we got. So if you sold policy to how many people? 6400. This is very interesting, very practical as well. As a part of insurance company, you sold policies to 6,400 people. So all people are rated as 0% discount. I mean, level 1. The rating is at a 0% level. After 1 year, in 2015, 25% of them they moved to this and they got 0% discount. They didn't get any discount, that means. And 4800, they got 30% discount on their premium. Then after another year, I mean, we multiplied using transition matrix. You remember the probabilities, the fractions I said. You multiply with 6400. This is the total number of policy holders. If you multiply 6400 to these numbers, 4 by 16, 3 by 16, 9 by 16, you will get an absolute number. These are the people. And 3600, they're enjoying 60% discount on their premium. That's quite high number. And here 30% they're getting, here 0%. You go to the next year, 3600, here 200, 700, 721, 3600. Next year, that was the question for 3 years. So 700 will not get any discount. I think this is 2100. Mm, 64, right? 36, 36. I think this is 2100. You can check it. You can add everything. You should get this one. So these many people will get 30% discount. These many people will get 60% discount. Now, if you want to find the stationary distribution, you start with this. You have to get the same. You find the equations. You take the extra one. You solve it. You get this. Although, I mean, I can take these things, but the stationary distribution, if I take this number, I I will not get a proper number. Okay, I can say you practically, because 13 6400, 13 is not divisible by 6400. So these are the probabilities I've written. If you want to check it, you can check something which is divisible by 13. If you start with, suppose, 1300 people, I'm talking about long term stationary distribution, steady state distribution, long run distribution. If you start with this one, these are the probabilities. In the long run, what will happen? 1 upon 13 means 100 people. 100 people will be receiving 0% discount. 300 people will be receiving 30% discount. 900 people will be receiving 60% discount. The highest level discount in the long run. Okay, so we can use that and we can do something more. But yeah, this much for today's class. If you enjoyed, please like and share this video and subscribe to our channel to keep up with our latest content. Thank you.